This video is about a project in sensor studies area that uses Arduino technology to create a mechanical sunflower. The main goal is to receive information from 4 LDRs and thus aiming a solar platform towards the sun, amplifying its radiation. The amazing team who created this flower is Bernardo Hackerman, Joanna, Energy Master, Tomas, the mechanic, Amanda, the lightkeeper, Ines, the architect. With that said, let's begin. The first motors considered for this work were servos. However, these only have a 180-degree rotation angle, therefore stepper motors were chosen instead. These allow continuously full turns, which is perfect for the sunflower. The stepper is connected to a driver, which is then connected to the Arduino board to allow a better control of its position. The sun's position is given by the 4 LDRs displayed equidistantly around the flower. LDRs are light-dependent resistances, and according to their variation, we can map the intensity peaks and drive the motor into motion to the highest intensity peak. Once the flower is correctly positioned, the solar panels are able to generate the maximum energy. These are located at the top of flower in a platform with a 45-degree angle. The 4 panels are connected in parallel to maximize the current output. In this part, the team started by defining pin variables, required constants, and evoking necessary the library, which in this case was the custom stepper library. In the void setup, the motor parameters were defined, either for the speed per minute and for steps per rotation. In the first part of the loop, it is retrieved the LDR's values from the analog pins and immediately mapped to a scale of 0 to 100. As for the second part, these values are compared by several if conditions, as shown in the example, to drive the motor into the specific position. To make that possible, the rotate left and rotate right functions were created. As it can be seen, they use basic library functions, making them extraordinarily simple. The materials used in this project had to meet certain specifications. They have to be light, tough, cheap, and have low environmental impact. The chamber, where the Arduino and batteries are located, was made from cardboard. For the sunflower stalk, the team used a simple straw. As for the solar panel platform, the material chosen was styrofoam, because it is light and provides a supportive structure to the panels. The team also 3D printed 2 pieces from thermohardening plastic. An environment-friendly view was considered while planning the battery management of the circuit. It was decided that the energy generated by the solar panels should be used to power the circuit, but since charging and discharging the same battery proved to be a complicated task, the team decided to use 2 batteries. One that powers the circuit while the other is charged by the solar panels. When the battery that powers the circuit runs low, it is switched by the one being charged. The components used in this part were 2 lithium batteries, one of them in a power bank with a removable case. 1 DC-DC converter appropriate to charge the batteries with the solar panels. The battery powering the circuit was put in the power bank so it would feed the Arduino. The DC-DC converter chip protects the solar panels by preventing the batteries from discharging backward through the panels during nighttime using a blocking diode, while also charging the battery with constant current. The mechanical sunflower. Although this device is a working mechanism, does not mean that there is no room for improvement. In a future perspective, there are still some aspects that could be optimized, such as the implementation of new rotational axis, for example, rotate up and down, and not only right or left. Change the Arduino code in order to increase the sunflower stopping points, instead of limiting the mechanism to 4 points. To visualize the current generated on the system, a current sensor and a LCD display should be implemented for further improvements. Lastly, the energy management could be upgraded by implementing a single battery system.